Let me take one more example where the values are like is in the form of sum of the products, sum of the min terms, where the values are like 1, 4, 5, 7, 9, 12 and 13. 9, 13. Can we able to implement this particular expression, sum of the products expression, in terms of multiplexer? Right? Basically, can we implement with the help of 16 by 1 MUX? Is it possible to implement with the help of 16 by 1 MUX? Yes, right? It is easy. As we are going to do the direct connections. Right? S3, S2, S1, S0, and for 1 you have to make it as 1. For 4 also you have to make it as 1. For 5 you have to make it as 1. 7, 9, 12 and 13 1. And all the remaining you are going to make simply as 0. This is the way you can able to implement 16 by 1 MUX for the given sum of the products expression. Right? For example, I want to implement the same thing with the help of 8 by 1 MUX. With the help of 8 by 1 MUX. Then how we are going to do? That's the question, right? So this is 0, 1, 2, 3, 4, 5, 6, 7. So you are going to have S2, S1, S0. S2, S1, S0. Now try to solve it. So you are going to get many possibilities, right? So if I am going to start with 4 zeros, 0001, 0010, 0011, 0100, 0101, 110, 111, 1000, 1001, 1010, 1011, 1100, 1101, 1110, all 4 ones. 4 1, right? Means these will be like S2, S3, S2, S1, S0, and then it is going to have the output. The output. What is the output you are expecting? When it should be 1 ma? Your 1 should be for 1 is 1, 4 is 1, 5 also 1, 7, 9, 12. 12 is 8 plus 4, 12 and 13 1. And all the remaining things are max terms. So they are given here as min terms, so you can do like this, right? Now if you want to simplify this, what we can do in terms of 3 variables? You can take out like S3 variable. S3 variable, when S3 variable has input 0 0, what about its output? Its output is like its input is like S3, S2, S1 as 0 0 0, it will be like S0, right? Similarly here it will be simply 0, here it will be simply 1, it will be simply S0, here also S0, 0, 1, 0, right? Then based upon the way we solve, we can able to change its select lines, right? So I can change the select lines as S3, S2, S1. Now what might be the inputs for 0? It will be S0, 0, 1, S0, S0, 0, 1, 0. This is the way you can able to solve 8 by 1 MUX. Okay, meaning that you can able to solve 16 by 1 MUX using 8 by 1 MUX. Now can we try to do it with help of 4 by 1 MUX? Yes, we can do, right? How? Right. So for example, let me try to do this one. Right. So if I am going to take it as 4 by 1 MUX, you are going to have 4 inputs obviously, and 2 select lines and 1 output, right? Now, so basically you can make assumption like this, right? So you can consider S3, S2 as inputs, S3, S2 as inputs, right? If I take S3, S2 as input, what will happen? These all will be as same only. This all will be as same, right? So meaning that S1, S0 is going to be changed. S1, S0 is going to be changed. So if you want to identify this, what is going to happen? You can make simply some kind of circuit. Like for example, let me try to do if I take all the things, so we are going to have actually 16 variable map. So S3, S2, S1, S0, S0, right? So or else the another way is what we can do now. You can consider this as one variable. Am I right? Because all are same, I can consider it as one variable, and I can take the remaining two as two separate variables. I can able to solve it. I can get a certain expression. That expression you need to give it as input, right? For example, let me try to do this particular procedure first. Right? Try to fill all the locations. So you have to fill the locations like 1, 4, 5, 7, right? 1, 4, 5, 7. Is it 7? Yes. 8, 9, 10, 11, 12, and 13. Is it okay? 1, 4, 5, 7, 9, like almost 3, 3, 6, 7. 3, 6, 7, right? All are done. Right, now how can we do now? We can able to combine, like for example, if I want to get like this is 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 1, 0, right? Guys, you know already what are these inputs? These inputs are S3, S2. These inputs are S3, S2. Right? As these inputs are S3, S2, we have to take only these two cases. Take only these two cases. If I am going to take these two cases, what is going to happen? You will get the values, right? So if you are going to consider this as one minterm and this as one minterm, because I cannot able to directly form a maximum subcube, right? So then what is the value you are going to get? So right, so try to observe here. So if S3, S2, okay. Is there any mistake? What happened, ma? So let me know if there is any mistake. So let me clarify. This as 0, 1, 2, 3. Okay, I think here I should not write, right? Let me redraw the structure. It will be S3, S2, S1, S0. These values are like 0, 0, 0, 1, 1, 0, 1. Sorry, this should be 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, right? So now tell me guys, so first one is 1 you will get here, 4 you are going to get, 5, very good, 7, 9 will be, I think 8, 9, right, 9, and 12, 13, 10, 11, 12 and 13, good, right? So now as you already solved S3, S2, so you need to find out for 0, 0. For 0, 0, what is the output you may expect? This 0, 1. For 0, 0, you need to expect the output as 0, 0, 0, 1. Meaning that I can able to get the maximum subcube of size only this particular one. So you can write it as what, ma? S1 bar, S0. S1 bar, S0. Meaning that for S3, S2, if you are going to get input, you need to have the input as S1 bar, S0. Similarly, if you are going to get the input as 0, 1, what might be the outputs will be possible for me? Can I able to combine these two as 1? And can I able to combine these two as 1? Yes, right? If I am going to combine the first subcube, what might be the answer? So the answer will be, which is not changing, right? Which is not changing is S1 bar. S1 bar. For a second subcube, which is not changing, S0. Is it correct? Similarly, if I want to get the 1 1 as output, can I able to form a maximum subcube of size 2? Yes. So then your input will be S1 bar. So this should be like, you have to make clear. This is 1 1, right? S1 bar. Similarly, for this, for 1 0, what might be the input? S1 bar, S1. So this is the respect to 4 by 1 MUX. Respect to 4 by 1 MUX, right? Fine. Or else what you can do now? You can take this as one particular case. This as one variable like k, and this has one some variable. At the time, what is going to happen? Try to observe. You are going to get k as one variable, s1, s0 you are going to get. Now try to represent these values 0 1 0 0. 0 1 0 0 if you are going to represent, for 1 you are going to get the 1. You are going to get the 1, and all the things you made it as zeros. You made it as 0. When you made it as 0, for this what you are going to write the expression? Again the same thing. S1 like this will be again 0 0, 0 1, 1 1, 1 0. Again you are going to get only S1 bar S0. S1 bar S0, right? So you should not consider the third literal, because third literal you are going to include here, right? So that's the reason you can able to get the same answer. This is the way you can able to simplify one 16 variable like 4 variable expression into 8 by 1, 16 by 1 MUX, or 8 by 1 MUX, or 4 by 1 MUX. Similarly, you can go with the 2 by 1 MUX also. Depending upon the requirement, you have to solve.